Deep background in both OLTP and business intelligence applications. He's worked with SQL for over 20 years and is still learning it and amazed at what's possible with the product. And then he's on the handout, the meeting announcement, it has his information on his geekswithlog.net SQL monger. Oops, never mind. But he's going to be talking about simplifying and improving your SQL queries with CTEs and Windows functioning. You should have all picked up a handout for evaluations. If you turn those in at the end.
And one of the books is actually a book on SQL Windows Functions by Itzhak Ben-Gan, so it's a good book. Good afternoon, everyone. How are you all doing? Is the lunch all right? All right. I have teenagers at home, so we eat way too much pizza, so one more pizza not necessary. All right, let's get going here. Close that. One more, I gotta close my email. I need to get the link started now.
So I see palm trees.
All right, so I just lost presenting.
Palm trees?
Nope.
No up there. Yeah, I know. I see palm trees. She's delusional.
All right. I actually gave this talk a few weeks ago at Data.net. So if you were at Data.net in my presentation there, you can go ahead and leave. You've already seen it. So the event that is I actually have the slides out there if you want to download them in a couple slides.
It's not presenting anymore. It's not presenting.
Oh, it did lose the link, lost its present. Love it. If that happens again, let me know, because I can only see the side screen over here while it's presenting. So we'll get going here. So again, the talk is out there. I have the files embedded in the slide deck. I have it on slideshare.net. I also have it on my SkyDrive. I'll show you those here in a sec. Just a quick note about Covenant Technology Partners. We're a Microsoft Gold partner for SharePoint BI and Silver partner on a few other items I can't remember. Our main focus is SharePoint, enterprise installations, public-facing websites done with SharePoint, extranet portals, you name it, content management workflow, as well as BI. So our focus is SharePoint, delivering SharePoint solutions, and I'm head of the BI practice, and we're always looking for people. If you know .NET developers that also know SharePoint, go ahead and contact us. We're always looking for good people. And as far as the presentation goes, if you want to grab the slides, they're on slideshare.net/ClaytonGroom. You can download them from there if you want to walk through locally or try out the sample files as we go through. I also put a quick link for my SkyDrive. I have this presentation, a few others out there as well. Basic outline, what we're going to cover. Some basics on SQL, which most of you hopefully know. Thinking in steps, baselining your performance, keeping everything that you do kind of in stages so that you get things working or figured out. You don't go, how did I do that 5 steps ago? I should have kept that. Kind of a process I've used over the years to fine-tune things and make things better. And also learn what's new and refactor your old code. So what I want to talk about today is something that many of you may not have even touched on yet. How many have used the new windowing functions in SQL 2005, 2008, 2012? Very timid hands. I mean, come on, guys. Row number. You use row number. Okay, you're using a Windows function, but that's basically the only one most people know how to use. There's also rank, percentile. There's a few other functions, and we're going to cover a number of them. This is a pretty deep topic, so in about an hour, we're going to scratch the surface of it up pretty good, but there's still a lot more depth to go into. And I put some links at the end of this to go out to some more presentations and I keep finding more. I keep Googling and binging and finding more and more people are blogging on this topic, different problem sets, and there's a lot of good material starting to generate around functions. Also want to then go through a bunch of examples. So we're going to knock through the slides, maybe 15, 20 minutes, and then the rest of the time will be demonstrations. All right, so the objective. Think in sets. I originally presented this for developers, not DBA SQL type. So if this is too slow, I'll just long. Get your feet wet with new functionality. In other words, when a new version of SQL is out there, download books online, look in the What's New section, and get that CTE and try it out. A lot of these new features are really, really groundbreaking and really make a difference to existing applications. So sometimes things like column or store indexes. You have system where you just want to be able to improve the performance on some basic queries. Adding a column store index, no skin off your bone, off your hand, so to speak. Added the capability to major reports run 100 times faster or more. The spatial data, all kinds of really great, cool things. But a lot of what I end up doing is working with ETL and business intelligence solutions. And I've been doing this, like I said, for almost 20 years now. And came up with all kinds of tricks to be able to do things like year-to-date, month-to-date totals, and then various things like that. They were really ugly systems, but they worked. But then I learned analysis services. I didn't have to do that anymore. I could do analysis services. Guess what? Now you can do a lot of these things in SQL and do it very simply and just as fast, almost as fast as in a special purpose application just like analysis services. So lots of fun stuff. Also want to cover common table expressions a little bit because they kind of come in handy when they work with functions. I think all of you are aware of thinking in sets, not thinking procedurally and looping, using cursors. If you have to use a cursor, you're doing something wrong, typically. There are very few cases where you really need to use a cursor. There's other options like outer apply and other methods. So one of the tricks I like to do when I'm hitting a tough problem is I'll diagram. I'll diagram what all the tables, what are the columns on the table I'm getting, what am I doing with filtering on it, am I grouping it, am I counting it? So I'll often make just a scratch sheet of paper where I diagram it out and figure out in advance what my joins are going to be, figure out just really quick what I got to do. So a lot of times you start writing a query and then you realize, oh, I got to bring this table, oh, I got to limit this set by that. Sit down and just think it through and map it out, and you have to bring another piece in, you kind of already got the framework in place and you're not screwing things up. So it's just another way to kind of plan in advance and think things through. You can do Venn diagrams. I like kind of the tree approach because it looks like an ER diagram and it just makes a lot more sense to me. But again, I don't have a good visual of it because I do it on a piece of paper, scratch when I'm done, and just throw it away. Set-based approaches. A lot of the things you're probably familiar with right now and use correlated subqueries. Like, for example, an effective date. I need to limit my rows to all the latest effective date values. That uses a correlated subquery. Or I'll say from select and have a subset that I'm using there. So that's the approaches you're probably using today. Or you might be using temp tables. Select, create a temp table, populate it, and use that query. What I'm going to show with you today is you don't need to do that. You can use common table expressions to, in effect, generate any table you need at any level of granularity, and then use that into query. One thing that I haven't done much work with yet, but I know is out there, is the merge operator. You can use that to create upserts. That's something that .NET devs, when they learn about that, love it, because if they're using a procedure-based approach, they only have to write one block of code instead of two to be able to manage the code. And it's also handy sometimes in ETL situations. And again, outer apply, where you need to apply a function or something to a set of code. So, a couple books I want to recommend, two of my favorite authors. I don't know, how many of you guys are Weird Al fans? Oh, come on. There's more Weird Al fans than people who know about windowing functions. That's great. So, one of the songs, White and Nerdy, was kind of our theme song when we started our company because that was kind of what we were, a bunch of nerdy guys. And so one of the lines in that song is, you know, the only question I thought was hard was, do I like Kirk or do I like Picard? You know? And so these are my two favorite SQL authors. It's Ben Gann and Joe Telco. I followed Joe Telco way back when I was a network administrator. I kept all his SQL puzzles, and I learned a ton from this guy. So I always recommend their books if I can. Like you said, we have the windowing function book up here in the table. Around. These are great guys, great authors, and I have to recommend them. I've learned a ton from them, and I have almost all their books on my shelf with references there. All right, so basic steps we want to take when we're doing development and trying out new things. We want to check your performance. We want to see, is this really fast? So a good idea is to use the ABCC free proc cache to clear out any cache procedures so that if you're trying different versions of SQL, you're getting consistent timings. You're not necessarily using cache again. Then also use set statistics IO on, set statistics time on. So dump out some additional information without having to go to using the whole tree view of trace or a show plan. You can actually get some nice little numbers. What I often do is I'll cut and paste them into my query text so that I have what was my run. And then if I play with indexes, I'll run it again and I'll see what's improved. So it's a good way to kind of self-document as you go through this. The other thing is keep versions of your code. So I'll start off a lot of times with premise query, like I'm testing this out, selecting a subset, working with it, and I'm creating columns and calculations. But as I do that, and I try to work things out, I'll copy that block of code, and then I'll hash it up and do other things with it. I'll make versions as I approach my target. And that's really handy because a lot of times you can look at that final solution and go, how did I arrive at that? Why did I do that? Well, if you have that trail, you can see why. But then also, sometimes you need to go back. You'll get all the way down a rabbit hole and find that you really messed up the code, right? And if I just save the 3 versions back, if I can get that file back, I'd be happy. Well, you're in a query window. It's not there anymore. It's gone. But if you kind of keep those copies as you go, then you've got fallback. So, I mean, it's not writing procs and checking them in. It's writing queries and testing things, and you want to keep those versions together. It's just a handy approach to take. Common table expressions. How many know about use common table expressions? Good number of you. They take the place of temp tables in a lot of senses. You can have a lot of really cool things done with them. They enable recursive joins, which is a very cool feature, which you can like create something out of nothing just with recursion. They do have some limitations. I discovered this one when I first started working with them back about 2007. Worked on a project and I did all this cool stuff, and I was doing projections into the future, and I had all this stuff working in views, and then the last step was basically do the recursive piece. And you cannot do a group by or a having clause on the recursive part of CTE. You'll get an error. Doesn't support it. So then I had to like back. I kept my different versions. I did back up 5 steps. Take it down. Outer joins are also not allowed in that recursive piece. Another part. You can handle it away, on the first queries we solve. All right. The main reason I like them though is that last point in the center set of bullets. It's more readable and easier to maintain. It's more of a building block approach. Typically, when I write and use store procedures, or temp tables within store procedures, I would declare and define the temp table first. I would never use a select to define it. Now you got a block of code defining a table, populate the table, and you can use the table. And so you end up with a lot of code. The CTE, you can define your table and query in one step. Now use it in another query, maybe join out to another set of tables, do some aggregation. So it's a very stepwise building process. When you read the code, it really makes sense. Once you understand how CTEs operate, these are much much more real code. A lot of times you can aliases on the tables, CTE names, and make it a lot more understandable. Someone has to read code. So an example, CTEs all have to start with a statement and a name. And after that, as, and then select inside the parenthetical. You want to add multiple CTEs, you just put a comma, CTE name, as, and then another parenthetical block inside it. But it has to end with the select, it turns out. So that's the basic structure. So this is an example we'll run later. So just a simple way to calculate a total and a percent total. So what we're doing in this query is getting the sum of the sales amount from the fact table. So now I'm grouping it by the customer and getting the total sales for that customer. Now I have a table called CTE totals. All it has is customer key, total customer sales. Now in my second query, the select, I can join that generated table back to my original fact table and now use that in a calculation to take each sale amount for each individual sale and divide that by the total sales to get 45% sales. So this is normally how you would do something like percent of sales. Very simple. And what I'm going to show you with windowing functions is you can do it very easily in single select. So there's a lot simpler ways to do things using functions. I won't say that it's always easier. You have to get familiar with windowing functions. But once you do, what you can do with it is absolutely amazing. It's all kinds of fun stuff. So, simple example there. Next slide. Looks like I lost sharing again. All right, so we should be sharing the secondary monitor again. And we have our CTE example. Now, I'll warn you, I have to look over here because I won't duplicate my monitor. So, if you can't hear me or when someone raises their hand with a question, you have to shout at me too. And of course, this is the left, not the right. There we go. We have that first example query where we calculated total sales.
You have
and
Zoom it, Clayton?
Zoom it. I can.
Here you go.
Code, not the.
That's cool. I couldn't see either.
And the second one, a little more complex. So in other words, this one I wanted to show using two common table expressions and a result query. So here I'm pulling customer totals, product totals, and then doing a percent of customer and percent of product. And all the examples that I'm running are either from AdventureWorks or AdventureWorks DW. It doesn't really matter if it's the 2008 or 2012 version. The data. So if you want to run these and try them out, samples are all there. Okay. All right, on to windowing functions. Windowing functions have a very specific structure. And I've got some diagram slides to kind of explain what that structure is. But each one starts out with a function, so like row number, rank, percentile, some function. And the functions are in different categories and can have empty parentheses or quotation marks. This piece is over, and then over states partition and an order by. Now, this is on SQL 2012. 2008 R2, we have a somewhat reduced subset. There's no over clause. No order by clause. And then the other piece that order by has options, a row or a range. These parts, what we're able to do is create an aggregate over our data set of what we want. So I could be returning rows of detail at the detail level, and then summarize, give me the total product across all time, across all prior months, prior 3 months, by 1,000 rows, whatever I want to slice it. I can window and create a frame of reference around my map, go get that data. We're going to walk through a bunch of examples to show how that works. Okay, so the first slide example here, very similar to what we were doing before. So we're getting total sales amount and percent of customer total, and doing it with a single select statement instead of using CTE. So again, I have sum of the sales amount. So my function in this case is sum, our normal sum function. It's one of the windowing functions. Over partition by customer key as customer sales amount. So what that does is it says, give me the sum for every customer key. So it's going to group by customer key, selected rows, total. Sum of sales amount over nothing, over an empty set, parentheses, gives me all. So it gives me a grand total. The next step, I'm actually calculating percent. So I'm taking the sum of the sales amount divided by partition by customer. So that will give me the percent of customer total, and then percent of total overall is I'm taking that sum of sales amounts for everything, dividing that into set. Any questions on that?
No group by?
No group by. Isn't that cool?
Yeah.
Because it's whatever level you're returning the data set at. That's okay. You're creating a frame. We have a bunch more options to look at here in terms of how that works. And this is just starting. We need to get into the order line. Okay, so I tried to diagram out using Excel what we're actually doing. So the first thing is you're setting a frame, or the subset of rows that the window function is going to act on. So let me click. Okay, so the yellow frame is the all. So that yellow frame, that's where we're saying over empty set, it's returning everything. Whereas the red frame, that's the sum over the customer key. So it's breaking down my set of data into each of those frames, totals within those. So just to highlight it another way, each aggregate is going to go for all customers, for each product, for each customer, products for each customer. Another way of looking at it is looking at it at row level. One thing I didn't talk about is the rows between clause. So what we showed right now was back to the query. So what we showed was just using an over clause. We didn't do any ordering on it. So in this case, we're going to partition a little different, and we're ordering it by product and date. So here I'm going to get the sum of the sales amount. I can say over partition by product, key, and year. So what I'm doing here is giving me, in effect, total per year per product. So now I've told it how I want to break the data apart, how I want it aggregated to my product key and my year. And that's also a month, so year and month. So I'm going to get a total per year per period, and I'm going to order that by product and order. My ultimate result is I get total per month for each product. And I can then also use the rows function to tell it how far back I want to go. So I can say rows between unbounded preceding, which means the start of my record set, to the current row. If you think about this, when I'm doing this, it's processing this for each row in my record set. So as my month changes, it's totally a different range. So when I first ran into this and understood it, I was like, oh, I can do year to date. I can do month to date. I can do any due date I want. And so I started mucking around with it. That's where I got the idea for this presentation. It was like, woohoo! Because I've been working on cubes and creating time calculation dimensions and measures. and all this stuff, and it's like you can do it in SQL now, and it's just as easy. So, you know, and it's standard SQL. It's not using any tricks. It's just using standard SQL that's available. So the framing clause is actually one of the most important things in static. It has a tremendous number of options. So this is literally out of books online, but it shows you all the possibilities of what you can do. Let's just kind of walk through them. So rows, unbounded proceeding, that's everything. Give me everything. Rows, unsigned integer literal proceeding is a count of rows. So I could say, maybe the last, if I ordered it by, say, sales rep, sales volume, sending to me like top 10 sales guys, I could do something like that. Total top 10 salespeople versus bottom. And it's very easy to create that. Current row, that's always the row that's being returned. And execution. So I can say, give me from beginning of the row to 10 rows back. Give me that. I don't know why you want to do this. I actually use this to do prior year. If you want to do prior year. So we could walk through all these, but I think we'll want to get to some examples. Okay, on time. Range uses a count distinct, whereas rows is going to use the count of the rows. So if you have data in your table that's duplicated based on your partition, it's going to compress it and look at it as the same row. So it's a little different. I haven't quite puzzled out when I might use that or why I would want that, but I'm not that far into it. Against book yet, so I'm sure you'll have an example of how to use it. But again, you know, there's only so many hours a day, and spend all our time in C. So all the functions. The functions are broken down into aggregate, ranking, and statistical in the books online. So the functions we can use in the aggregate set are average, checksum aggregate, creates a checksum of the values in the group. So if you want to see if the total changed or something changed, create a checksum. Count big. Count big for the cases where you have more rows than integer support. Max, min, sum, standard deviation, deviation. E stands for
over the population.
Population, that's right. var and varp. And then ranking functions. There's two different ranking functions. One's called dense ranking or English ranking. That's where you say, I'm ranking, but I've tied for third. So tied for second. So I have 1, 2, 2, 4 versus 1, 2, 2, 3. So it's different ways of numbering ranking. So we'll run some examples of that. Tile and row number. Row number is handy for generating row number on a set. So if you want to order things or have some kind of a number out of that set, you can get the row number within each partition. So for example, if I group by day, the row number, I partition by year, I get 365 or 366 values. So it's really handy for generating numbers over the sets. An end tile, I'm not remembering off the top of my head. Windowing functions that are analytic. Cumulative distribution, first value, last value, which are really handy. You need to do closing open balance values.
What do you mean by analytic? I mean they're just that they're.
It's just a way of
grouping them. Okay.
Yeah, these are more statistical functions. For example, percentile continuous, percentile discrete. Percentile is basically saying if you've got, say, salaries for individuals and you got 200 people in your company, what percentile are you in? If your salary is, say, $75,000 and plop that into a percentile function of all the people in the company out of 65th percentile, that means you're median, means 65% of the people below your salary, and then the discrete does the same thing, but it's on discrete values. It doesn't interpret. Percentile, standard percentile will interpret. So if I have less than 100 values, it'll say, okay, you're at 65, well, you would really be at that percentage like 70. So it's more to the statistical minded, but we had to do a report for a company on one of our projects and had to generate code to do this for a report, and it was ugly. We even used the windowing functions, but it was only what was available at the time. And now it's like, you can rewrite that report, boom, that much faster and a lot simpler code to maintain. And percent rank is the relative rank of row. Some other new functions that I'm aware of, but I knew something was different when on 2012 when I tried to do a compute clause, and I got an error message, and I thought, what the heck? So I went and checked. Sure enough, compute's been deprecated, but I didn't find anything on what replaced it. And in my perusing the web, I came across a grouping clause here, and it in effect replaces compute clause with the added value that it returns the value for your record set. So it doesn't create a second record set, it adds some rows to it. And you can do grouping at every level of your group. So you can have multiple rows in Act. You have total, overall total, a product total, and customer total. You can turn those in sets. All right, we're ready for demonstration. So actually, while I get ready for that, here's some more references. So if you get the deck, I'll update the deck. I added a couple more to this that I found more recently, but there's some really, really great stuff out there in terms of ways to apply these statistically and other ways. Lots of good examples. So definitely want to encourage you to look at what's available as well on functions. Okay. So we were talking about CTEs when I left off, and I actually had one more demo that may be handy to some of you, and that's a calendar dimension using a common table expression, the cursive join. So a lot of times, I remember doing this the first time, I did it in Excel. I used Ralph Kimball's spreadsheet from his first book on data warehouse, our schema design. And put Excel function in the spreadsheet, copy them out, as many rows as you can get, then dump it out to a text file in SQL Server. Now, I don't even need a table. I don't even need anything to start with. I can generate all the values I need from the cursive join. So how that works is, take a look first. The first part of the query is I define my CTE, but I have a select here, and all I'm doing is picking my start date. So I'm saying, take my start date, cast as a date, and then follow that up with union. But what am I going to union to? I really don't have anything to union to. Well, I'm going to select the column I defined here, this anchor date, +1, from my common table expression. And it's going to do that recursively until I tell it to stop. But I have to tell it to stop. Otherwise, you know what happens with endless recursion. Well, actually, SQL has a limit of 100 loops before it'll stop on its own. So what I do is then put in an endpoint where I anchor date +1 into January 1st, 2009. If you want to do it more generic, I put some code in here that would go through the end of next year. An example. This is actually pretty cool. So let's go ahead and run it first without the option. We'll see what happens. I get an error. Maximum recursion of 100 has been exhausted. So I got 100 rows, 101 rows, basically, data. So if I want to run that again with option max recursion, I'll get all my data. Right? This is a great way also to generate a numbers table. I know a lot of people use a sequential number table for all kinds of things. This is another way you can generate that. And Dan actually has an example of that in his book. Okay. So next is, well, that's nice and all, but I want to do more, right? And we can just keep adding calculated columns to this query, generating out all the pieces, all the slicers I need for my time. So I just added month end, date, calendar year, a few others. Well, let's just keep going. I've got a view here that you can steal. I don't care. I beg, borrowed, and stole to create it. So highlight this and run it. And I've got a lot of really handy dates in there. So all kinds of stuff you can do. So just generate all that out of thin air. Time dimension. You can turn it into a view. When you select from the view, you have to remember to use that with option match return 0. So that's the only trick. I usually end up dumping it into a table as well, so I can create indexes on it. I'll often create a month level version of the view. Create just a month level. So that's another example of CTE. So I'm going to go ahead and close that window. And again, if you want the code, see me after, and I can put or I'll put the slide link up. We're all done, or right on, or whatever to you guys can stuff. Close those. Now let's get on to first example. So a lot of what we end up doing is losing our presentation from link. Eddie, I don't know if that does the recording. It doesn't. Okay. That's fine. Awesome. Okay, your trick is I got to stay on this monitor or I'm going to lose it again. All right, so first step what I want to do is old school, kind of show you subqueries with column values. This is another way we use subqueries and pull back data. This sucks. Never do this. If you see this, rewrite it now, okay? Because every one of these subqueries is a separate query. It's going to kill performance. So if you see code like this, fix it. It's just, trust me, I don't want to do this. So we're going to go ahead and run this with our stats turned on. We'll see exactly what I'm talking about. So there's a record that, oh, I came back 8 rows in very little time. So what did we end up with? It's really hard to read. Still pretty quick. 35 seconds, 24 reads, logical reads. All right, we can definitely do better than that. We are, you know what? We did do a free. Yes, we did. So the next example is using our windowing function. Again, get our same 8 rows. Now, logical reads 29, 2 milliseconds. So that's 35 milliseconds to 2 milliseconds. I'll take that. I should probably do that in all these. So that's a little easier. And I think that was it for the example. No, sorry. The other is to use the CTE. So this was kind of new old school, right? Run that. 5 milliseconds and 29 logical reads. So almost as fast. Definitely faster than subqueries and columns, but still, you get the idea. A lot more code to arrive at the same result. You get used to these. They're also supported in one form or another on most major databases. So stick with the ANSI implementation, ANSI functions on your code is very important. And your skills too. So you learn this, you've got to write something on Oracle, you can do it. I should say, I hate to admit how much Oracle code and DB2 code and security code I've written, but I'm always happy to come back to CTE. All right, ranking functions. These are ones I'm probably least familiar with. but we'll talk about it. So, first one is just row number. I want to get a row number. Number of the rows based on the order I return. So if I return and send an order on amount or something like that, like in this case I'm saying row number over ordered by sales year to date descending. So I get my sales numbers from best to worst. So I got my number one sales guy or gal in this case. I want to introduce Candy. Candy Breezy, if you want to just say hi, Candy works for me. She's on our sales
Everybody.
team.
Hello.
Joined us recently from Microsoft. So some of you may know Candy. So that's a simple way to do ranking. We also have the actual rank functions. Let's delete that. In this case, I'm going to do a row number, two different row numbers. One over postal code, ordered by postal code and sales year to date. The other by postal code, partitioned by postal code within a postal code, and ordered by postal code and sales year to date. Let's change that. Our ranking, and go down here, we'll notice at about row 7, we've got 14 rows, it goes 1 through 14, because that was our first overall ranking. Next one, it breaks, because these first ones are all in the same zip code. So within that zip code, my salespeople are ranked 1 through 6. Next zip code, I got 1, 2, 3, 4, 5, 6, 7, 8. So I got another set. Two different zip codes, you get two different sets. You can tell it, just give me my rank and my ordering any way I want. You can create a record set that allows you in an app to sort it, slice it by any values. If you want to give me the top end, bottom end, any of these attributes, you can have a query generate column that supports that query. Best use for these, if you're doing SQL reporting services reports against the SQL database, probably the place you use them the most, because you can take a lot of the heavy lifting off of reporting services to generate these totals. Next example. Here we've got rank and dense rank. We're doing a number of different things. So our sales rank by year, sales rank year, dense rank. What did I order my final set on now? This is when I was monkeying with the demo. So that's ordered by sales amount. So again, here's our overall ranking. So if I want to order by, let's just order by step. There's that. That's what I want to get. Year break, 2006, 2005. So the sales rank year, it's still doing it within the overall. So when I look at it, my top salesperson is only 8 overall within 2005 compared to all time. You could also get a rank, say, just give me the top person, top rank by year, and I'd have 1 through N within 2005, 1 through 2006, and so on. In this case, they're being ranked within that overall set. So I can say my top person in 2005 was only 8th overall. So interesting. A lot of interesting stuff. Again, like I said, I haven't used the ranking too much. Ranking's pretty straightforward stuff. Just taking a list and saying, give them to with the appropriate rank number tag to them. The difference with the dense ranking, repeated values go away, or actually, yeah, repeated values will be grouped. All right, we've got one more. That's a test. Not ready. Go on to number 3. No. This is the statistical function, standard deviation, so on. So in this case, using the functions to just select standard deviation on bonus amount. Say, okay, use this salary table, bonus, average bonus, variance for the population. I get those numbers. And if you're a statistician or you work with standard deviation, you know, you bands and drop into. So you can shoot those calculations very easily. You can do this in Excel, in analysis services, or it's one SQL for it. Okay, so here, another one. This is partition by department and salary rate. Do the same sort of thing, cumulative distribution, percent rank. And in this case, if we look at this data, we can see the top person within their band, so within information services, the top rate is $50 an hour. They come in at the percentile rank of 100. And the person here in the middle, you know, 66, 44, and so on. And the bottom person is at 0. Bottom rate is 27. So that's how percentile works. And one other here. Continuous and discrete. So they mostly are coming out the same, but there's only one member in each of those groups. When there's multiple members, it's going to come out a little bit different. So continuous, it's interpolating this value, saying 34 is above the middle of that band, whereas the distinct will give me the exact one that's in that band. So that's the difference in the function. That's more of a statistician thing about it. One more. I'll run one more here. And these are just examples that I pulled up and tweaked with to show the different functions. And this is one I was monkeying with and not finished with, but I was going to work to say, give me my previous salary. So I wanted to create a query, give someone's salary history. With the Lincoln functions. So this is your homework. I didn't finish this example, but it wouldn't be too hard to work with this bit. All right, grouping. This is that new function, grouping and grouping ID. Now, these are kind of weird because you normally think of a record set as only containing what you asked. When you put grouping on, it tacks on the totals. So let's go ahead and run this. Let's just say run our select first. Up. Let's do group by. And we get a record set with 3 rows in it. Right? And we've got this grouping item on here. And if I add float row with roll up, now get total 4 items. Now you'll notice this grouping ID grouping now gives me a number. Represent is the roll up level. So I can now use that a little more fun SQL, which most of you guys are probably familiar with using the case statement. So you have to know what they are, so you have to hard code this. I'm telling you I don't like about it. But you can say one grouping, ID, name, title is 0, and then job title else. When it's 1, total else is 3. So you have to play with it, find out what level to return it, and then create your case statement. When you're done, run this. You now get job title, like company total, facilities total, and the totals. So without having to write 3 different queries to pull those different totals together, it just does it. So it's pretty cool. More better functionality than we had. All right. Cumulative sales. So a lot of the examples following this are all sales. So I got to get base. So here's our typical query. Give me a sum of sales, and I want to try and get a running total. And we wait. And we wait. As it cranks through the data. So this example is a really bad example. What is it doing? It's doing a partition, right? Cross joint on I don't know how many million rows. I think this is the one where I flew in about 100 extra rows for testing power pivot. So we could be waiting a while. We're already 39, 40 seconds. Should we keep waiting?
Oh, no.
All right, just check.
I've never done a cross join.
But it will work. It will come back eventually with an answer. It's just not the best way to do it. So we can do that same thing using a common table expression. Voila. Get an answer. So let's take a look at what that took. So basically we're getting a row number, over ordering by customer key and order date, that's a row number, and then all the rest of the columns from that table. And then we're selecting from table expression A, joining back to cell B, on our customer keys, whatever the row number is less than the row number. So I've got all my previous rows to myself. So it's a much better way of doing it than cross-join on the dates. You saw how much faster that goes. Just like instant. Row 6. So another running totals example. This time we're going to use our window functions. Okay, so here, to make this work, I'm using the year and month functions over the order date to get the pieces I need to be able to create my window and or create my buckets, and get the sum of the sales amount and ranking over the order date. And order date and the sum of the sales amount. So this will give me a day level aggregate, and then use next step. Sorry, there's a Zoom again.
About time.
So I and so here we're going to do day level aggregates with rolling totals for month to date, quarter to date, and year to date, all in one query. Running total and same day prior year. So I'm going to run it just so you believe me it works, and then we'll go look at the code. There we have it. If you look at it, there's our sales amount, each sale amount, month to date, and you see they add up. I even pulled them over into Excel and double checked. Right. Quarter to date, year to date, and a running total. Year to prior year, go down to year breakpoint. So it's like a day over day sales. Okay, so there's the breakpoint for the year. And remember that first row number we had was 69.98. So it's looking back the same day in the prior year, getting the sales total. That's sort of stuff I end up normally doing in an MDX query with, parallel period. It's a little ugly. You got to do it over and over. It's very simple to do in a query. So how do we do it? Take this chair. The first trick was to do month to date. So to arrive at a month to date, I have to partition by something to break it down to month. To do that, I need to have year, month. So I put them in my set so I can group by them. So I'm grouping by order, date, product key, and year. And I have to have them in my partition as well. I'm going to partition by product key, year, and month. But on my order, just say by product key and order date. I order it based on my output record set. So now I get my total working correctly for all those slices of time. Same goes for order to date. A little trickier, I have to take our order over the order date to get that. And if I created a column to combine year and month together, I can use that. For example, versus this is. Again, it's the same structure of product key. And you notice we're going to start seeing some changes in these rows between. Right now, I have it rows between unbound and preceding row. That's going to be within that three. So it's going to go unbounded up to the beginning of the partition, start there up to the current row. That's why it keeps incrementing. The current row keeps moving. It's going down that table, keeps adding up. I'm not remember if there's any. So running total, again, it's just partitioned by the product key, no time element. Now it's going to roll it up by product across all. And now to do that prior year, I have that lag function. So now I just say lag 365 days. Now, it's not going to work for leap year, but hey. But you could do it. You could figure it out if you really wanted to. All right, next example. Day level aggregates. Now, this one is adding the overall total and product total. So let's go look at that chunk of code. So here, there's the overall sales amount running total. And annual sales, monthly sales, all product sales, annual product sales. And again, very similar, except I'm saying here, always the sales amount over everything, all the sales, company history of sales, by year, partition by year, by month, year and month, so on. And by product, partition by product, year. So this, I think, actually works out to help you understand it a little better and how it's working, as you see it kind of building in different places. The next example is going to get rid of the date and do it at one level. Typical refactoring. But you see what's possible here now. Now I have denominators. If I want to create any ratio calculations, I have all my denominators predefined. And this query ran one section and it's millions of rows. So, and if you put the column index, the in-memory indexing behind this, it's going to be faster. So here's a more interesting role. Let's look at months. And this one I have an issue using the transaction data to result in gaps by product transaction occurred. So in other words, I don't sell every product every day, and gaps in time. There's ways you can handle that by using CTE to generate all the dates. This example handles that. So this example, just for the record, does not handle the gaps. So that's just something to be aware of. So we're going to do basically the same calculation, but taking out the day levels. So you get month-level aggregates. And then I get a little fancy here, and I've done some additional calculations like rolling 13 periods, 12-month moving average, 3-month moving total, a few others. There you have it. So I don't have a lot of data. It's only a year's worth of data. But you can see the 3-month moving total. It builds out months to receipt. And 12-month moving average. Have a lot of data to roll into that, but it does declare and does work. And this is something worked on a project for lots of instances here from Watt Electric, where we took industry trend data and used 12-month moving average, 3-month moving average to generate, in effect, a prediction trend against their own corporate data. So we take nickel pricing, copper pricing, producer price index, run it through the same algorithm, and run their sales data, pipeline data through it, and match up what their predictors were, either before or after. So it's really a cool project. Did it all supporting services for Q. This, you can do it all from Q. So what I'm seeing, this is just me prognosticating, is need for the reason why we use tools like analysis services is for the aggregation and the calculation capabilities. And what I'm seeing now is a lot of those capabilities are in the SQL engine. So there's a lot of cases where you might not accomplish that. You can accomplish SQL 2012 memory, columnar in, store, and functions. I'm not going to say analysis services is dead. It's not. Tabular analysis services is awesome. Multi-functional is awesome.
But this might take the place of MDX, maybe.
Well, at some point. MDX is actually a very interesting, beautiful language. But
Difficult.
if I can do it and not have to go there, and I don't have to go there. I don't have to stand up another server, right? There's a lot of possibilities here.
Yeah.
So, I mean, I make my bread and butter with analysis services, so I'm kind of putting my neck out there to say this, but I learned SQL first, and I understand it probably best, and I can see that a lot of things just with straight SQL that you couldn't before. We used to rely on other tools and other techniques, and now we have to. So be aware of that. Your architect produces a solution. You might want to think that through. Yes, sir.
Was this only in 2012, or was any of this in like 2008 or 2?
There's a limited subset in R2. So the row number, rank, if you go to Books Online, go to previous versions, it'll list all the ones that are there. But it's the partition by and over clause are what's new in 2012. One thing to be aware of too, if you're using Azure, Azure does not support the full set of functions, even though the version number is higher. No, I ran into this. So I'm ready on to connect and fired up a comment because I was hoping it would be there and I'd have a great solution. You need to resort to on-premise database, but I'm sure Azure will be better every week. So the other piece, we've got all this great calculation going on, but we don't have the gaps in time figured out. We still got gaps. So to take care of that, I just did a quick query, say what's my min and max dates in that table, snagged those, and created my little CTE date. So I created the range of dates. So I have a table to pivot by and join to by date, so I don't end up with any gaps. Tested that, make sure that works. And now I should have contiguous amounts. And in cases where I don't have an amount, it'll just have a repeat. And again, use the CTE approach to generate the calendar. Have a calendar dimension. And I don't have to show that. We've already done that. And so now, if I got that, I can use that date, cross join, to get date, what's the products by date. Do the same thing again, but I got to go by month. E every day, sort by month. Do the same sort of thing at a month level, generate a month level table. Use that. And really what I'm doing here is I'm kind of stepping through a solution where I want to solve that problem with gaps. In my output, I want to fill in those gaps. Now let's do it, put it to use. So now I've got my month period. I'm going to get my data. Run that. Here's the dates where I don't have any sales data. And get spots where we got data. So if you have to generate a record set where you're, for example, counting the days where you have sales of a particular item, this will help solve that problem. Another technique, how you leverage CTE instead of a record solution. All right, we got a bag of things up here. That was, I said that's still too slow to take fast. Tell me why. No takers? A little bigger. We're using a clean join, which works, but isn't necessarily the fastest. So I'm going to make it a little tighter, faster. So again, we have our month and our product period and our result. I don't know if that was actually faster. I had tested that it was. That's 36.5 seconds. Now, what I want to get to, we're almost done. I've got 2 more examples. I'm almost done with this one. Some more interesting roll-ups if I want. This one. I did prior year calculations. So same period prior year, month level, prior month, rolling 13 periods. And let's just look at each of these. So same period prior year. I'm going to use the lag function. And I'm going to say new sales amount, lag 12, over partition by product key, order by product key year month. Oh, that's wrong. might have to draw one. So, what we're telling it to do is go back out of this ordered list for this product, go back 12 rows from my current row based on the year and a month, and do that out. So it's going to go back, or its prior year, back 12 months, turn the total. Prior month is very similar, but it's only back one. Back 1 month. In rolling 13 periods, I'm going to say, use the rows function instead, say rows between 12 preceding, so 12 back, my current one. And 12-month moving average. So it goes between 11, see, I can see the average. And this was a little trickier. This is a 12-month moving average, and the characteristic of this calculation is I have to have 12 months to produce it. I have 12 months. I can't use this calculation. It's not going to be an average of 11, 10, or 9, or 8. So to make this one work, a little trickier, but all I had to do is say when count over the partition is equal to 12, then do the calculation. Let's return home. So you can nest these things. You're not limited to just doing one function. So I actually here
But you could pad it, right? You could make as a condition of your case statement to unconditionally divide by 12 if there were gaps.
Yes, if you wanted to,
If you had
average months that have left this, you should divide by the gap. Yes. So this was, I've got several examples in here. 12-month moving average. V2 is a better one, right? And then a moving total. A lot of times, you've got all these things put together and it gets really big and ugly. You can also use your common table expressions to generate an aggregated set and then do a much simpler select off of that. It uses the column names. So when you look at it, you're not looking at case when, X, Y, Z, all this junk. You read it, you have to think, what is it doing? Where if the name says count of months, oh, okay, I'm taking count of months at 12, then whatever. So sometimes, even though you can expand this, have it all in one select state, sometimes better to break it down and name things so that you have a nice clean variable, if you want to call it that, to work with. And a lot of times it doesn't really affect you that much. So it's worth trying. Get it to work. If the performance can be helped by expanding it, you go and take code for that state code, CTE, bring it down. All right, I'm running out of time. 8 minutes. For example.
Take what you need.
Contact, okay?
No, you take what you need.
Yeah, so in this case, I've got a whole bunch of examples in this one on the various methods of calculating those this one might be the one that takes it. So again, we got our 12-month average moving total, 3-month count of preceding. So you see here, on preceding 12, there's no preceding data, so that they go up until I get here, I get 12. Now when I have 12 months, now I can actually get the 12 months show up. And then my rate of change calculation, which is a percent between minus 100, 0 and 1. The rate of change between 1 and minus 1. So you actually calculate that almost equal to the rate of change. And this is to do an MDX took about 2 pages of script to get all the pieces to do this. And so kind of like my test case, well, I'm going to see if I can do it. Did it all come out? It's come out right. So it's pretty fun. And I think there's one last chunk. So this is an example of kind of a high level of what the code looks like you. But behind that were calculations for each one of them. A lot of these. And this, I think, is fine. It's just more of the same. Just a little bit better each time. And it's doing all those calculations, all that data in 142 milliseconds total time. So aggregating millions of rows, grouping by months, years, quarters, rolling periods, all that, boom. No time at all. All right, we got a couple other examples. That was number 6. Last item I think here is the checksum ag. This is a little oddball one, and I'm just throwing it kind of at the end because I was unaware of it, but you guys might be too. You can actually get a checksum on a table.
You're just talking about like a hash number, right?
Yeah.
You're calling it checksum.
Yep.
Okay.
So just say checksum ag, cast quantity is int from my product. So boom, it takes my quantity, gives me a hashtag. So what I got? 262. So let's run this next block. So I'm going to update my quantity 125 where it's 100. Run that. And select that same value back. Now I get 287. This is checksum. So I remember writing procs to do stuff like this. I did a proc to basically checksum text of procedure do, so I could see if something changed. I had my own little table. I wrote this function would go through sys comments and parse out all words, white space, and hash it. You can do something very similar with this function. So it's very cool what's in there. Just another little tidbit. You never know. You might need it somewhere. There. Now you know about it. Any questions, any comments? I think there's a lot more to this topic. I think it'd be fun to say, hey, if you guys dig in and come up with a great example, share it with the group next time, give them one of the little SQL Lite sections. I want to thank everybody, and Julie, great.